On this page of notes, we're going to look at the odd and even properties of our various trig functions. Now, although we have not actually graphed these functions yet, I've provided some graphs here to help us understand what their properties are going to be, odd or even. Now, it is also important that in the copy that you have, the labels for these graphs are backwards. Please make sure that your graph on the very first graph has been labeled, or should now be labeled, cosine. Change that. This second graph needs to be changed so that it is labeled sine. This bottom graph here should be labeled secant, and this graph here should be labeled cosecant. Your printout might currently be wrong, so please fix those immediately. Now, jumping into these graphs, even though you're not familiar with these graphs, what we did do at the beginning of the school year was we understood graphs as odd and even algebraically. So let's first just review our rotational symmetry around origin and our y-axis. So quickly labeling our graphs as their types of symmetry, we can identify that the cosine graph has y-axis symmetry. The sine graph I can see would have rotational symmetry. Tangent would also have rotational symmetry around origin. Secant, logically our reciprocal of cosine, will have y-axis symmetry. Cosecant, our reciprocal of sine, is going to have rotational symmetry. And cotangent, our reciprocal of tangent, will have rotational symmetry as well. So we can see that the only ones that have y-axis symmetry are cosine and its reciprocal. Now, earlier in the year, we learned that even functions have y-axis symmetry. And we also learned that algebraically, that would mean that f of negative x equals f of x. We learned that odd functions have rotational symmetry. Now you may want to write a note that that does mean around origin. It's not any rotational symmetry, it's particularly about origin. And we learned algebraically that f of negative x would then be equal to negative f of x. Understanding this algebraic relationship, we can come up here and we can now understand that cosine is an even function. We can learn that sine is an odd function. Tangent is an odd function. That means that the reciprocals are going to behave in the same fashion. So secant is even, cosecant is odd, cotangent is odd. Now, the reason this is useful is oftentimes we will be given problems that have a negative angle in them, and we can use our odd and even properties to rewrite that negative in a different form. So looking down here at the bottom, for example, if sine is an odd function, sine of negative x should be equal to negative sine of x. If I have cosine of negative x, since cosine is even, that means that that's exactly the same as cosine of x. So I don't need to write the negative at all. Tangent is odd, so tangent of negative x, instead of writing the negative on the inside, I can write it on the outside and give myself a nice positive angle. I can do the same thing with the reciprocal functions. I can write negative cosecant of x instead of having the negative on the inside. For secant, it's even, so I don't even need to write it at all. For cotangent, it's odd, so I'm going to move it to the outside. So some quick little exercises. This is what some of our problems might look like. Sine of a negative 2 theta, since sine is odd, I'm going to move the negative to the outside and write it as negative sine of a positive 2 theta. Cosine is even, so I don't need to write that negative on the inside at all. It doesn't need to be moved. I can mentally drop it and just rewrite this problem as cosine of 3 theta. Notice I can choose to write the parentheses or not write the parentheses. Either one is acceptable. On tangent, I need to move my negative to the outside, so I'm going to write a middle step on this one. Now I can see these two negatives will multiply with each other, so my final answer turns out to be positive. So that's just a quick little introduction into our odd and even properties for sine and cosine.